So hi everyone, welcome to our next video series related to the Verilog. So in today's discussion, we will be discussing one more important topic on how does the unary reduction operators work. Okay. So generally, we are aware that in Verilog, we are having the unary reduction operators like OR, XOR, XNOR, and uh, and all the remaining things because almost NAND, NOR, and so which are almost the same symbols, NAND, NOR, which are almost the same symbols like the bitwise operators. But the difference is, as the name suggests, the unary reduction operator, we are going to use only one variable. We are going to use this operator at one particular variable. For suppose, so generally in one of the few particular places when I was discussing this, I have observed the students having a lots of confusion in this, so I thought of making a separate video on this particular operators. So in order to understand how this particular operators work, let us consider a 4-bit variable. Okay, so let me consider the value to be 1010, and let me consider I'm applying XOR operation. Okay, so now if I'm writing this one like 1010, how this particular unary reduction operators work is, from the LSB, from the LSB, I'm sorry, from the LSB, we are going to take the least significant 2 bits. So in this particular LSB, these are the least significant 2 bits. What is the XOR value of 1 and 0? The result will be 1. And later, I'm going to take this corresponding result and I'm going to XOR it with this one. So which gives me 1 again. And later, I'm going to take the result along with this particular value, which gives me 1 XOR 1 will be 0. Is that okay? This is how actually the inside the simulators consider the unary reduction operators in this way. Okay, so if we want to discuss one more example, let us discuss. But before discussing, let us write a small program to check whether I have discussed it in a right way or not. So when I wanted to write down a very small program, let me consider module test and module. Yes. Okay, so let me consider a variable reg and let the name of the variable be a. Let us consider a packed array which is of 3 down to 0. Next, this is going to be the initial, begin and the end. Yes, so let me save it like ytd12. Yes, so now let us consider the value a is equals to, what was the value which we have considered? 1010. So a is equals to 4 tick b 1010. So I wanted the result directly. So let me take, and what is the output? Sorry, what is the output of this one? It is 1-bit output. So let me take the reg out, which is of 1-bit. So later let us consider out is equals to XOR a. And now let me use the dollar display display. Out is percentage B, comma, out. Okay. So let me run this code to check what is the output. And I got it here like 0. So here also I got the output like 0. So I'm right. So now let me take one more simple example. So in this corresponding, in the next example, let me consider, so and 1010. Okay. So first we are going to apply the operation on these two. So which gives me 0. Later the resultant in these two, which gives me 0. And later this 1 and this 0, and the result is 0. So the final result will be 0. So let us again check that with the help of the code. So let me modify this as end, and let me run the code. Yes, the answer is 0. So what, this is what we have got. But most of the students, when I was teaching Verilog, the doubt from the side of the students was, sir, why do we need to consider that the unary reduction operator should work in the same way? Why not in the other ways? So there is a reason behind it. Okay. So in order to just explain you that particular reason, directly let me take an example of 4 tick B 101x. Okay. So let us first try to do the XOR. Okay, XOR 101x. So here, if I'm trying to do the XOR operation in between these two, one and don't care, obviously when don't care is involved, the result will be don't care. So later when I'm trying to do the XOR operation between 0 and don't care, so 0 and don't care, which is nothing but 0 bar don't care or don't care bar 0, so which results in an don't care. And later again 1 and the don't care, so the result will be the don't care. Okay. Now similarly, let me consider 101 don't care. So when I'm trying to do the AND operation between 1 and don't care, the result will be don't care. And when I'm trying to do the AND operation between 0 and don't care, the result will be 0. And when I'm trying to do the operation between 1 and 0, the result will be 0. So let me check whether I'm right or wrong. So here the A is nothing but the don't care which I have taken. First let me perform the XOR operation. So if I'm performing the XOR operation, the result is don't care, and we have seen that whatever we have got also is the don't care. Now let me do the AND operation. If I'm performing this AND operation, so now you can see that the result is 0. So the result is 0. So generally, if at all, if we are directly doing it in a regular way, there are more chances that we may miss. So that's the reason why how the simulators are going to understand this unary reduction operators, there is a necessity for us to understand it in the same way. Okay. Thanks for watching. Please do comment in the section below. And if you want still different types of the content, please let me know. I will do that particular content. Thank you. Thank you one and all. Thanks for watching. We'll meet you back with another video.